Welcome to all. Today we have to perform second lab for our module that is called ENSA. In this module, we have discussing about the Ospf. So now the particularly this lab 2.3.11 is about to determine and the designated router which is called DR and the backup designated router that is called uh, BDR. So here we have a topology, and if we see that this topology, we have a switch S1 which is connected with our A router on G0/1 interface, and the switch second interface FA0/1 which is connected with the router B RB, and the interface is G0/0. And similarly with the router C switch using their interface G02. Now if you see this topology, uh, by looking this topology, we immediately see that we immediately in our mind think about it. It's called a broadcast network. Why it's called a broadcast network, or we say it's a multicast access network? Because all the routers are connected with a Ethernet device that is called switch. So remember that the election of a designated router and backup designated router is always perform on a network which have multi-access type of network, means broadcast access. So the objective of this lab is there are two parts. In part one, we have to examine the DR and BDR, and we have to change their rows. And in the part two, we have modified the Ospf priority and forces the election process. Addressing table is given to you. This are the host name of the routers, their interfaces are given, and the IP addresses along with their subnet mask. So in this activity, you will examine DR and BDR rows and what the rows changes when there is a change in the network. Then you will also modify the priority to control the rows and forces a new election process. Finally, you will verify the routers are filling the desired role or not. So in the step one, first we have to examine the routers one by one. So when you have to wait for the 50 seconds, so they said in the instruction, if there is a amber color, don't run the command, wait for the till the color of this port should be green. So you can use this forward button to make it more forward, and within a second it will be green. Now to verify the Ospf neighbor state, we know the most important command. It's show IP Ospf neighbor. So one by one we run this command, and to verify whether the current DR about the current DR and BDR, and if the router shows full DR other, it means the router is not a DR or a BDR. So this is the identification. So on a router A, I have to run show IP Ospf neighbor. So if I run this command show IPSPF number, I make it little bit big and see this output is same like here we see. So it's this is a neighbor ID and state is full. This is another router neighbor ID, state is full. Priority, this priority is 2 and this neighbor priority is 1. Now this neighbor, it's a full and its neighbor is DR, and this neighbor it's a BDR. So it means on a router A, both its neighbor which have a this neighbor ID, one is called DR, second one is called BDR. Now if we go with the router B, router B, neighbor show IP OSPF neighbor. So again here see this neighbor of router B, it's in full state and it is DR, and this neighbor ID of a router B neighbor is full and it is DR, other. So means for router B, uh, for router B, one neighbor is DR and other one is DR other. One is DR, second one is DR other. Now similarly, if we go with the router C and I run this command again, so now you see again for they have two neighbors IDs. One is BDR and second one is DR other. So by looking all this information, what do you think, which router is your DR? First we have to select which router is DR. So on router C neighbors, they have a BDR, they have a DR other. Okay, got my point? But for router B, the neighbor is DR and neighbor is DR other. And similarly for router A, the neighbor is DR and neighbor is BDR. It means for our case, router C become a DR. Okay, router C become our DR. And regardless this, we have one more command, show IP Ospf, and this command we have show IP protocol. Okay, in this command the mention is router ID 3333 192.168.31.3. It's a router C router ID. Okay, and if you see on router A, 1.33 is a router ID of router C and it is DR. I hope you understand that point. So it means this neighbor ID, it's a DR and that neighbor ID belongs to the router C. If I click on router C, I run the command show IP protocol, I see that same ID. So it means router C in our case is a DR. Okay, similarly we run this one, same output I will show you. So which router is the DR? It's a router C. Second, which router is BDR? Now I hope all of you understand this. It's router B. So if you see here on router B output, one is DR and the second neighbor is DR other. So definitely router B is a BDR, backup designated router. Okay, now the router which have this ID 31.11 is DR other. So this ID is for router A. So I run here command show IP protocol. So what is the router ID? This one 192.168.31.11. And here in output they also say for the router B output same. You got my point? I make it simultaneously so you can manage very clearly. See here, see here. Both router C router ID is 192.168.31.33. So for the router B, this is my DR other. Got my point? So this is how you identify the things. Now they said in step 3, turn on IPOSPF adjacent debugging. So there is a one command debug. As all we know, debug is a command to view the packets which are exchanged between the routers. So we can monitor the DR and BDR election process when we enable the debug command. So on router A and router B, I can enable the debug command, debug IP OSPF adjacencies. Okay, this is a command, so I enable here on router A. Then I go to the router B, same command, debug IP OSPF adjacencies. So now the debugging is enabled and you see this message debugging is on. So whatever the messages during the DR and BDR processes routers send to each other, you will see here. Now how we start the process again. So they said in the part A, disable the gigabit ethernet 0 interface of on router C. So this is the router C. This G00 interface we have to make it disable. So disable means we have to run the command shutdown. So I config T, go to the interface G0/0 and make it shutdown. So you see this all messages are coming here. Neighbor is down, neighbor is down. Okay. Now what I do, I make router C, which is my DR. Okay, it is down. What will be happen? So they said wait about the 30-second for the dead timer as expire on a router A and both routers. Once the dead timer is expired, means this is not their neighbor. So you have a concept of hello and dead interval, as I already discussed in the theory part. Hello interval is used, it's a message, keep alive message after every second. Ospf enable routers and 10 hello messages that I am here. And dead interval means it's uh, how long it will be wait to be how long it able to become a neighbor. After a particular time they break the neighbor relationship, so that is called the dead interval. Normally it's a 4 times of a hello packets. Now if you almost the 30-second will be go there. Now what is what you are thinking that which router become a now DR, because our RC DR is down. So as we know about the OSPF, the backup designated router BDR become a DR. So in my case RB is a backup BDR, backup designated router. So once the designated router is down, and this router become a DR. So how we verify it? So can check it with the help of a command. Okay. So now go to this one, show IP OSPF neighbor. So now you see router B, this one router B only have one neighbor, and that is connected with BDR. So the now router A become backup designated router. Okay, and if you I can click on a router A and run the same command, show IP OSPF neighbor. Now if you notice that this interface is going down for the neighbor, but if you see here 31.22 interface, this is the IP address of loopback IP address of router B. It's now become DR. So router B become a DR and router A become a backup designated router. Okay, now come to the next part. Restore the gigabit ethernet 0/0 interface on RC and re-enable the link between RC on a switch. So how we re-enable? It's very simple. Same command. What I do, no shut to enable the interface. Again I go for the no shut. After that you see there is amber color. If you go fast forward it will be immediately green. So it save your time. Now what will happen? Will router C again become a DR? Let's see. So IP OSPF neighbor. So router C get the information that again 311 is BDR and 3122 router B it's DR other, and 31.11 is my backup DR. Now router A, because the highest priority, second highest priority means. Now if you see router C Router C router ID is 192.168.31.33, and it is the highest IP among them. So that's why it's become a DR again. So if I click on router A, so DR ID is 31.33. Have you noticed that in debugging message that 192.168 is a 31.33 is a DR ID and BDR ID is 31.11. So this is backup designated router, and now this is designated router. So it's immediately changed. So the question is here, they're asking us, did DR and BDR rows are changed? You have to explain. So no, because the Ospf does not update the DR and BDR when the existing one are active. So this is the reason for it. Now come to the C part. We have already verified this same thing. If the show IP Ospf neighbor command does not return RB as a DR and RA as a backup DR, turns off debug on RA and RB with the undebug all command and retry the step 4 and step 5 again. Okay, so actually what have to do, let's see how to disable the debugging. U space all, this is the command to disable all debugging which we are enabled. So you will see that message. Also I disable here. Okay, so here on router C, router B, on I hope you remember one command, clear IP OSPF process. So this command will remove all the established agencies and whatever they establish. It will make again new neighbor relationship. So you select yes, so it will remove all the neighbor relationship, and it will take time to make a new neighbor relationship. Similarly for router A, clear IP OSPF process. Yes, select Y, and it's also restart. Okay, now if I come here again, router C, show IP OSPF neighbor, so C, now router C 31.22, 31.22, router B again backup designated router, and 31.11 again DR other, and router C by himself as a designated router, show IP protocol. So router ID is 31.33. Okay, this is the router ID, and for the router A neighbor, if I see show IP OSPF neighbor, it will show that router C is the DR. So DR, which router ID? 31.33, and we know that 192.168.31.33 is a router ID for router C. Now we've finished this one. Okay, now we have the next part. Yeah, so step 6, disable the gigabit Ethernet 00 interface on router B. Now it's turn to router B, which is our backup designated router. We have to disable G00 interface. What will happen if our backup designated router is down? So we'll see config T interface G0/0 shut down. Okay, so now they ask us disable the link. Okay, we did it. According to the debug output on RA, which routers will be elected as DR and which routers was elected as BR? So what do you think? What should be the answer? So no roles did not change because the current DR and BDR is still active. A router that comes online with a higher router ID will not assume the BDR role until the BDR is fail. So we have to first down the BDR, then it will consider as next router as a backup designated router. If they make a neighbor relationship and DR is exists and BDR is exists, so it will not select any other BDR. Now we enable the link between RB and the switch, so we re-enable it, and no shut. So the question is now, according according to the debug output of RA, which router was elected as DR and which router was elected as BDR. So for that one, RC is now BDR and RA is now DR. When the DR fails, RB become the DR. So RC is now our backup designated router. Let's see here. Show IP Ospf neighbor. Okay. Okay, now this one is 7 part. We did it according to the debug. Okay, now step 7 again, RB, enable the link between and wait for, I already told about this part. So router C now become in our case, use the show IP command on router C, which status of router C is now. So we run this command on router C, show IP OSPF interface. So now this router is currently as backup designated router with this ID. The designated router ID is 31.33. See here, 31.33 is a designated router IP, and backup designated router IP 31.11, which is our router A. So this is the lab about how to modify and changes the thing selection process of DR and BDR. The rule is always remember same. I just recall for you, if there is no loopback is available on a router, so the router interface which have a highest IP address, router physical interfaces which has highest IP address become the router ID. Secondly, if there is a loopback interface, then they give the priority loopback interface IP to select as a router ID instead of physical interface. And if the router have more than one loopback interfaces, then they select the highest loopback IP address to become a router ID. So that's the reason in this topology we have loopback already configured, so they didn't consider the physical interface IP address to select a router ID. They only just go for the loopback interface IP. And if you configure the router ID manually with the command of router-id, then that command has highest priority in the selection of a router ID. So these are the things which we already discussed in a theory part. Now we can also modify the OSPF priorities to force the election process of DR and BDR. To change the DR and BDR, use the IPOSPF priority command and to configure on the gigabit Ethernet 0/0 port of each router with the following OSPF interface priority. So now for router A, we have to set the priority 200. So this is my router A. I go to the router A and go to the G00 / interface. config T, interface G0/0, IP Ospf priority T. So what the priority they ask me on a router A, it's 200. Then for router B, it's 100. I already in this interface G0/0, but again I show you int G0/0 IP Ospf priority 100. And for router C, interface G0/0 IP Ospf priority 1. Okay, remember one more point. If you don't want to make a router to take a part in a election process of DR and BDR, you make their priority 0. If you make their priority 0, that particular router will not participate in the election process of DR and BDR. Now after this one, we configure this all priorities, force on election process by resetting the OSPF processes. So I told you, once the neighbor relationship is built, it is very difficult to elect a new router ID. So what we have to do, once you configure the priority, again we have to clear the OSPF processes. So what I have to do here, config first I have to exit here, clear. This is a command, IP OSPF processes. This is a command to clear all the OSPF processes on particular this router. So there you have to select Y. Yes, it will down all the neighbor relationship and try to make a new neighbor relationship. So with this router is 31.11. Okay, so IP OSPF neighbor. So now see, I make router A priority 1, which is, so they set one my neighbor with 31.22 IP. Where is the 31.22? This one, router B. Its priority is 100. We configure a priority on router B is 100, and there it's a backup designated router. Okay, and 31.33 is router C router ID, where we configure the priority one, what, 1. That is a default priority. Okay, so they set this, yeah, they said this router is DR other. So for router A, one router is backup designated router, second router is DR other. So what about router A itself? It's a DR now, because they have highest priority. For the router A, what is the priority? It's 200. So when you configure the priority and the highest priority to make a router with the highest priority, that router become a designated router. And the second highest become the backup designated router. So if I show on a router A, show IP OSPF neighbor, so 31.11 on a router B, yeah, on router A. So for router B, if you notice that 31.11 is router A ID, which the priority we have set 200. It's a designated router. So in this is the topology which we have configured today. And according to, okay, the last part is verify the DR and BDR election were successfully. Okay, we use a fast forward according to output, show IP OSPF neighbor command on the routers, which router is now DR and which router is now the BDR. So the answer is very simple. Now the router have with the highest priority, that's why it's a DR, and the second highest priority is going to with router B, it's a backup designated router. So thank you so much for this video.